Hello, my name is Mark Hauser, the Ecology Outreach Manager with Friends of the Chicago River. I'd like to welcome you to Creating a Litter-Free Chicago Calumet River System. This workshop is proudly presented by the Center for Great Lakes Literacy and by Friends of the Chicago River. It is focused on the issue of litter in our river from a teacher's perspective, teaching a litter-free curriculum, leading a litter-free service learning project, including workdays, and collecting litter-free data for academic research and for classroom lessons. Friends of the Chicago River is a member of the Litter-Free Chicago and Calumet River Task Force. This extraordinary partnership also includes the Mars Wrigley Foundation, the Shedd Aquarium, Loyola University Chicago, the Metropolitan Water Reclamation District of Greater Chicago, REI, and Waste Management. Our featured presenter for this video is Dr. Tim Hoellein. Tim is an associate professor at Loyola University Chicago and will be talking about collecting litter-free data for academic research and for classroom lessons.
Can offer some background perspective and then just a few little snippets of what we've been finding. So yeah, Mark, I had that same thing in mind. I have a few bits of information about the broader topic of trash and plastic pollution in the world generally, and then a few highlights of some research projects that we've done regionally, and then a bit about what I've done to try to make this information useful through outreach and communication, and most importantly for this education. So this is a picture that a friend of mine sent who was working on water pollution. They were studying the impacts of wastewater. So they're looking for bacteria, for chemicals, and they're collecting water samples and taking these notes. But I thought this picture was a good illustration because yes, those problems are really important, but so obvious to us when you see this picture is there's another problem kind of staring us in the face, which is this issue of trash in the environment. The problem is because we see it all the time, you know, we see litter everywhere we go outside. It's one of those things that can be easy to overlook. You kind of stop seeing it. And I think this is a good example of how we can sometimes start to not see that trash. But in my research group here, we've been studying that material. We've been picking up litter. The term we use sometimes is anthropogenic litter, just meaning trash, of all types and sizes. And you can see it's a really diverse assemblage of materials, metal, styrofoam, plastic, rubber, textiles. And some of it's really small. We do some studies here on very tiny microscopic pieces of litter, like microplastic, which I've tried to highlight with these arrows. And this is not a problem that's limited to urban areas like Chicago or the region. It's a global issue. So this is an island in the South Pacific where nobody lives. It's uninhabited. It's one of the most remote places on Earth, but it's covered in trash. And it's covered in trash because the global ocean currents move trash all over the world and can leave it in a place like this. And we know that there's all sorts of biological interactions that can go on. There's problems of entanglement. This is a duck here in the Chicago River. This is a story from a couple years ago, I think highlighted by Friends of the Chicago River. There's entanglement, ingestion. These are plastic bags removed from the stomach of a whale. And not only the kind of physical component, but there are chemicals associated with the plastic, both embedded in plastic that can come out when it's ingested, and then plastic in the environment can actually kind of concentrate and absorb some of the pollution that's already out there. And in fact, this field of study on plastic pollution or litter is just one part of this emerging concept called the Anthropocene era. And the idea is that the Earth is in a new geologic age, the Anthropocene or the human era. And we can call it that because now people and the activity of people has a permanent imprint on the geologic record. We've changed the biodiversity, altered the climate, sea level, and the arrow here is pointing to novel entities. That's a kind of a catch-all term that refers to all of the synthetic compounds that humans have made, like plastic and trash, that can become a part of the fossil record, essentially. So a theoretical geologist in thousands of years can look back and see this change in the fossil record of the Earth. And the reason we're finding so much litter, and in particular plastic, out in the world is because the rate of production has been accelerating since it started to be produced around the mid-century. So this is a model of plastic production from 1950 to 2015, and it's divided up by all of the polymer types. You recognize PVC, maybe PP is polypropylene, polystyrene, etc. All of those different kinds of polymers are, more is being produced every year than the year before. So that's the production rate. And then this is the waste production of plastic. Makes sense that the amount we're producing and using is accelerating. So the amount of plastic waste that we're generating at a global scale is also accelerating. In this case, it's divided up not by the type of plastic, but by the kind of sector that it's used in. And you can see that the dominant one here is packaging. And that's not just packaging for, you know, boxes and shipping, but that also includes food packaging, which is a lot of the litter that we see in the environment. And accordingly, because the amount of plastic is increasing, the amount of plastic waste is increasing, the amount of studies that have documented litter all over the world is also increasing. This has become a kind of rapidly growing field of research. And this is a website from Germany that kind of tracks all of the publications, scientific publications on litter, where they're conducted, how much they find, etc. And I think it's a useful point because essentially wherever we look for litter, in particular plastic, we find it. It's all over the world. It's in the sea ice, it's in the atmosphere, it's in the deepest part of the ocean. So litter is a global in scope, and it's pervasive to all parts of the world. So that's kind of a sad introduction, I guess, but hopefully a few good kind of useful facts to ground some of the work that we've been doing right here. And I just pulled up a few figures, and basically the questions we're looking at are real simple and not too different from probably what your students are wondering too. Where is it and what's there? You know, how much litter are we finding? One of the key observations we make is that litter in our streams, in our water bodies, is not evenly distributed. It collects, and it collects in the same kinds of places that natural litter accumulates, so leaf litter or wood, fine sediments and soils. So we have these debris accumulations that are natural, and these are important for stream ecosystems because the leaf litter and other organic material is an important food resource for insects, for crayfish, for fish. And so these are key parts of the kind of life of the stream. And we see that litter is accumulating in those same places. So here's another shot. You can see it doesn't take much, a couple of logs, a couple of obstructions, and you get some pretty impressive accumulations of trash. So we sought to quantify this by just going out to these debris dams and dismantling them. So they kind of like took them apart to measure what was in there. This takes some good-spirited students, so they're really good attitudes for digging through trash like this. And then we go to other areas nearby that don't have these natural obstructions. And here's what we find. We did this study in Chicago and Baltimore. Here is our debris dam locations. Here's the kind of adjacent areas in the streams that don't have the debris dam. And we see the same pattern. There's a lot more trash accumulating in these kind of concentrated locations. And much of that trash is plastic. So this is various plastic in blue, and then in yellow here is styrofoam. So both of those are plastic. So kind of a simple take-home point. There's much more litter in the debris dams, and it's mostly plastic. We've also sought to answer this same kind of question by collaborating with volunteers. We worked with the Adopt a Beach program that Terry mentioned, and also with the Litter Task Force, specifically the Shed Aquarium runs a program called the Kayak for Conservation program. And we developed a data sheet that's part of the package we'll be talking about today. So this is available for anyone who wants to pick up trash on the river, but has been really nice for this kayak program in particular. you can see there's a lot of different categories here. We base this on the data sheet that's used by the Alliance for the Great Lakes to pick up trash on the beaches, which is in turn based on one for the Ocean Conservancy, which is a global program. But we modified it a little bit for the things that we find most commonly in the river. So if I can just zoom in here, well, to one type of category, food-related litter is really common in our collection. And we divide it not just, so we have the volunteers tally what they find, and we're interested not in just in the item that they find, if it's a cup or a bottle, but we also ask them to kind of subcategorize that by material. So if they find a cup, we'd like to know, is it paper, is it styrofoam, et cetera, because we can really learn a lot about the kind of assemblage of trash from this data. So here's an example of what it looks like. This is the litter collection from last year, from 2020. So this was ongoing even during the pandemic. So out of all the litter items that were collected, here's the material categories that we have. And what stands out to me is about 75% of the material is plastic. So what we call plastic and styrofoam. Styrofoam is foamed polystyrene, it's plastic as well. That makes up 75% of the trash. Furthermore, we can look at the types of plastic, for example, that we find by materials. And you know, we've got a lot of different items for them to choose from on that data sheet. But again, it's mostly made up of a couple of categories. So about 75% of that plastic is made up of these categories down here. We have fragments as the largest category. So we can't necessarily identify the original source. And the others are related to eating and drinking. So food wrappers and packaging, as well as bottles, lids, and jars. So a lot of this is food waste. All right, and then I thought I'd just show one more. This is from a kind of bigger perspective. We've also repeated these studies across different watersheds. So in this case, we were looking at litter abundance in urban streams, and then ones that were a little more kind of agricultural outside the city. In our area, there's not a lot of natural reference conditions left. You're either in the city or suburbs, or you're in the agricultural region. That's just kind of the nature of the development of our state. But here we go. We've got a few that were forested. So we've got some agricultural sites, forested sites, and then urban streams. And this is the amount of litter that we're finding at those sites. And probably to no one's surprise, we find more trash at the urban sites. There's more sources of this material, especially because a lot of it is eating and drinking related waste. But this is the last one I'll show you. And I know it's busy, but I like this figure because it shows the relative abundance of litter by, again, by material type over here on this side. And I've divided it by urban and agricultural streams. So in our urban streams, we see, if you look at the composition from one to the next, they're pretty different. You know, one is dominated by construction debris, and the other one's really all plastic. And then these are variable from each other. But when we look at the composition of the urban streams, they're much more similar to each other. We're seeing the same kinds of trash composition out there, and it's really dominated by plastic and glass, which in turn are generated from food and drinking related items. All right, so last bit here is just to hopefully put some context into the programs we've been working in. In addition to the Kayak for Conservation program and the Litter Task Force, the Alliance for the Great Lakes runs the Adopt a Beach program, which has been a wonderful source of collaboration for me and my students as we pick up trash with them, but also analyze their 30-year record of litter on the beaches. That's been a great source of research projects and of learning about litter on the beach. We also work with students who do some artwork. I try to do some of this myself as well. As we collect so much trash, it's nice if we can use it to make some kind of statement. I and my students try to talk to whoever we can about this kind of data that we're doing, and speak with legislators if possible. Luckily, we've also had that chance to do some work with education. So one of my collaborators at Loyola, Lara Smetana, is a former advisor to Micah, who's one of our next speakers. And we've been interested in saying, well, how do we use this idea of litter collection as a tool for teaching, for not only teaching about the environment, but also about conservation, about data analysis, and about communication. So we were able to publish a few papers that have a curriculum designed to do this. So I'm sure we'll hear more about that coming up. And then we've had a lot of collaborations on these projects. So I appreciate all of the teamwork that's gone into accomplishing this work. And that wraps it up. So hopefully I'm on time. And I'm happy to take any questions.
I have one if nobody else does. Tim, are there any schools that you actually receive a regular stream of data from?
No. The data stream that we get through the task force has been primarily through the Kayak for Conservation program, which is near Goose Island on the North Branch,
Okay.
and from the little Calumet, where they do some similar programs with canoeing. But no, we don't receive any from schools. And I know that there's another group called Urban Rivers. So they've been putting together these floating wetlands in the river right there near North Avenue. And they've been having their volunteers and stewards of their wetlands do litter collection and use the same form. And we haven't received those. So, you know, it strikes me if you or we are thinking about grant applications or how to organize things going forward, it would be nice to have a kind of streamlined or perhaps electronic or app-based way of doing this kind of data collection that might help kind of consolidate it all in the same place.
Yeah, I will say that Urban Rivers is actually the partner with Skinner North. Kimber, that's your go-to destination for your field trips. They were going to help you with the macroinvertebrate surveys and a place to access the river for chemistry. But it's good to hear that they're kind of in the pipeline for giving you data, Dr. Hoellein, and Skinner North could be a regular gatherer of data and actually contribute to that.
Yeah,
I would love that. And I would love to talk at a later time about like what format, how, if we could do like is there an app that we could download data into? I'm trying to get my kids to do like the different apps, but please, yes. The more that we could make this a permanent thing with the kids, like they'll talk to each other, and like we're doing it with the 8th graders. So the 7th graders would love that input as well. Anything to make it, the more we can contribute, the better.
That would be wonderful. We don't have an app that we were using for this data sheet, but there are apps out there, like Marine Debris Tracker is one. I think there's one called Literati. It's like a little pun, literati. I think that kind of thing is really appealing to students because the records can be so easy to update, access, and then create figures from. We're doing it kind of a little bit kind of the old-fashioned way on paper, and then entering it into a spreadsheet and then generating data. And certainly that process is valuable, but if there could be a slightly more automated system, I think the students would be really keyed into that.
Yeah, when you go out on field trips, Kimber, and if you generate the data sheets, now that you know who Dr. Hoellein is, you could actually submit them directly. Or if you send them to me or you have them on the field trip, I'll make sure that he gets them. Because one of our goals at Friends of the Chicago River, being part of the task force, is we would like to get as much data as we can, because that'll inform some kind of solution to this. So same goes for
and stuff.
Yeah. And the data has been useful for hopefully for solutions already. You know, before the pandemic, we were sharing this data with a Cook County commissioner who was interested in reviewing styrofoam policies for the county, specifically for takeout containers. You know, and a lot of what we find on the river are pieces of styrofoam, and those are, you know, while we can't say for sure, they're pretty obviously from food packaging. These are coffee cups, takeout containers, other kinds of food packaging that are getting in the river, and they persist for a long time. And so this was prior to the pandemic, but when that occurred, obviously takeout for restaurants was such a key part of the business that this sort of thing took a back seat. So I don't know where it'll go going forward as we emerge, hopefully, from this pandemic era. But the data's here, and I think is unique and of interest right now for public policy.
Yeah, thank you very much. Mac, you mentioned that you might want to actually do litter pickup on your field trips and maybe even gather data as well.
Sure. Yes, for sure. We in the past we've just kind of just done it on our own just to kind of clean up if we had some extra time. But yeah, I would love to actually make it part of our field trip and collect data. We do it when we go to the Bahamas. I bring students to the Bahamas, and again, we go to an island there that is uninhabited, and we do a beach cleanup there, and we collect that data. But that's just internally for us. But I would like to do something similar at the river.
I think one advantage of this is, and I'm sure Michael has a good perspective on this, but to have the students think about, it's a good way of just doing the scientific method. They can ask them, what do you think you're going to find out there? That's essentially a hypothesis. And then you can generate a pie chart or a graph like this. And then they can address whether they were right or not, or what they actually found. It's a very simple and straightforward, and I think intuitive and hands-on, a tangible approach towards scientific prediction, analysis, and interpretation.
Yeah, I'd like to speak to that tangible part because water quality in the Chicago River, when we have students explore it, and maybe some of the teachers you could talk to this, but it's often very ethereal. It's often the distance. Like, we're trying to monitor water quality and it doesn't change all that much over time, but seeing the problem with the litter in the river is very visceral. I mean, a lot of kids have a reaction to what they find in the river. They're really disgusted by it. And so picking that up is an immediate gratification that they're doing something. I don't know if you want to talk to that, Tim.
Yeah, I agree. And it's not, I think, yeah, it's tangible, and it's easy for people to say, yeah, there's the litter that obviously was created by a person, that somehow it was human activity that is generating that problem. And making that connection between human activity and pollution in a really tangible way, I think opens the door towards thinking about other problems that perhaps are invisible or a little bit more conceptual, like chemicals that might be in the water, or like changes in the atmosphere that might be affecting the climate. So I think it's tangible and a good sort of brick, in the building of understanding human impacts on a broader scale.